Hello students, in this video we are going to discuss about rolling motion on a rough inclined plane. See, here you are seeing a rough inclined plane. On this plane we have some object which is rolling down. So this object can be anything. It can be a sphere, it can be a cylinder, it can be a disc. So we are going to derive expression for a general. We are going to derive a general expression. Then whatever body that is asked in the question, so you can write the moment of inertia of that body. Okay, let us first see what are the forces that is acting on this rolling down body. You know very well, weight acts down. So weight is the force which is acting down. And see, this angle is theta. If this is theta, this will be theta. So now I can resolute this mg, that is weight, into its components. So I can write this portion. This will be mg cos theta, this one, and this will be mg sin theta. And see, this one, this is the normal reaction. Either you can write n or you can write r. So this is the normal reaction which is acting. Normal is always acting perpendicular to the body. And here is one more force. Can you guess? Yes, friction. The friction force. So you know, friction always acts opposite to the direction of motion. So this body is rolling down, so friction is basically acting in this way. So this body comes down with the acceleration a. See students, one more thing also you have to understand for this rolling motion. See, the body which is rolling down possesses two types of motions. So one is translatory motion, which you all know. See, the another one is rotational motion. And if you consider the kinetic energy also, so you have to write, if you are going to write kinetic energy, we have to write both the kinetic energies we have to write. We have to write rotational kinetic energy, we have to write translatory kinetic energy as well. Okay, now let's write the formula for force. Yeah, first let us balance the force for translatory motion. So for translatory motion, so body is rolling down, so ma is the necessary force. Now let's see which is favoring and which is opposing. So you know, in the direction of ma you have mg sin theta. So mg sin theta is favoring, and you see which is acting opposite, frictional force of minus f. So I can take this as equation 1. So this is for translatory motion, we have balanced the forces. In the same manner, we have to write for rotational motion as well. So if you are writing for rotational motion, then we have to write for torque. So torque is the rotational analogy for force. So torque, you know the formula for torque, which is a force into force arm. This is radius of this object is a small r, so f into r, that is torque, which is helping for rolling motion. And you also know, students, you know the formula, another formula for torque in terms of moment of inertia, so which is I alpha. You know I very well. I is moment of inertia. Now we can equate these two equations, so we will get f into r is equal to I into alpha. So and from this we can write a formula for f, which is coming I alpha by small r. So I got some value for this frictional force f, and I can take this equation 2, and let me substitute this equation 2 in equation 1. So ma is equal to mg sin theta minus, and instead of f I can write I alpha by R. So now we can substitute the value of I. So because I have taken, I told you, generally I'm going to write a general expression. So moment of inertia, for general expression formula I can write mk squared. So I can use radius of gyration formula. I can write, instead of I can write mk squared. Instead of alpha I can write, a is equal to r alpha, that is linear acceleration is equal to r into angular acceleration. So alpha I can write a by r. So these two substitutions I can make I can substitute in the above equation. So I will get ma is equal to mg sine theta minus, so instead of I can write mk squared, and instead of alpha I can write a by r. So already I have one r, so it becomes a by r square. Now if you see m is there, mass is there in all the sides, you can cancel. So now you have two a terms, so you can bring it in one side. So you can write from this equation you can very well write the equation for acceleration of the body which is rolling down. So a, and this minus term I can bring this side, so this becomes a k squared by r squared is equal to g sine theta. So a I can take commonly out, so 1 plus k squared by r squared is equal to g sine theta, and I get a is equal to g sine theta by 1 plus k squared by r squared. So this is the formula for acceleration of the object which is rolling down. Next what we have to find is velocity, and we know the equations of motion v squared is equal to u squared plus 2as. So I am going to use this equation of motion. I know initial velocity is 0, so plus 2 into 2 into, instead of a I can put this value g sine theta by 1 plus k squared by r squared, and instead of this s is the actual, see this distance. So the body is rolling down, this object is rolling down, so the distance it covers while it rolls down, so this is s. And see the height of this inclined plane is h. So I can go for the right angle triangle, I can go for sine theta. The formula is opposite by hypotenuse, so it is h by s. So from this I can write s is equal to h by sine theta. So I'm going to use this substitute. Instead of s I'm going to write h by sine theta. So you can see this sine theta and sine theta getting cancelled, and you're getting v squared is equal to, so 2gh divided by 1 plus k squared by r squared, and if you want to write v, so you can write whole root, so you can put 2gh by 1 plus k squared by r squared. So this is the formula for velocity. So this is the velocity of the body that is rolling down. See students, this velocity equation is very important. Sometimes NEET question and JEE questions they ask based on this velocity also. Some one regular question is there, frequently asked one, a sphere, a cylinder and a ring which will fall down in an inclined plane. So using this formula you can answer easily. So maybe if possible I'll put a separate video. Yes, last thing what we have to find is time. So we need to calculate time. So for this also you can use equations of motion. V is equal to u plus at. So v is equal to at, again u becomes 0, so t is equal to v by a. So this is the simple formula, and you already have v with you, you already have a with you, so just simple substitution. So if you just simply substitute, you will get the answer for time as well. So let me do it. So t is equal to, so v I am going to substitute, so root 2gh. So I'm going to put root separately, root 1 plus k squared by r squared, and I have to divide it by a. So instead I am going to multiply the reciprocal, so 1 plus k squared by r squared by g sine theta. So what happens, see this one time it is getting cancelled, so root will come here, root will come to the numerator. And if g also, see this root g is there, that root g will get cancelled, and here root will come. So if you combine everything and write, see I have written in the other ways also. So I have taken 1 by sine theta outside, and every other thing is in root, so 2h by g 1 plus k squared by r squared, or I can take this sine theta inside, make it sine square theta. See students, you have all the three formulas. So you have equation for acceleration, you have equation for velocity, and you have equation for time for the object which is rolling down on an inclined plane.